Welcome to Info Minutes. We take problem on shear force and bending moment, and we consider overhang beam with uniformly varying load UDL, uniformly distributed load UDL, and point load. Problem statement is: draw axial force, shear force, and bending moment diagram for the beam as shown in the figure. So this is the loading diagram of the beam which is given in the problem. Also determine the maximum bending moment and point of contra flexure. So we see that we have a beam which has been supported at point B and D by means of hinge support and roller support respectively. AB is a part of overhang on the left hand side and DG is a part which is overhang on the right hand side. We have a uniformly varying load of intensity varying from 30 kN per meter to 0 between point A and B. We have an inclined load of 300 kN at point C. The inclination is given by this data. Also we have this uniformly distributed load of 15 kN per meter between E and F, and the respective spans for all the loads and the beam is given in the problem. So we've been asked to find out the axial shear force and bending moment diagram, and also we need to determine the maximum bending moment and point of contra flexure. So let's solve the problem. Solution. First thing, let us show the support reactions at hinge support and roller support B and D respectively. Now we see that since inclined forces are acting on beam, there will develop both horizontal and vertical support reaction at hinge support B. So let us show the support reactions at point B and D. We'll have a horizontal support reaction at point B denoted as HB and a vertical support reaction denoted by VB. Let the direction of horizontal support reaction and vertical support reaction be assumed to be rightward and upward respectively, and also there will be a vertical support reaction at point D denoted as VD where we have a roller support. So our first step is to determine the support reactions which are HB, VB and VD. So for this we make use of static equilibrium equation. Now since there are three unknowns, we make use of three static equilibrium equation which are summation of all moments about any point is equal to 0, summation of Fy which is the vertical forces is equal to 0, and summation of Fx which is the horizontal forces is equal to 0. Now let us apply our first static equilibrium equation at point B. So we have summation of all moments about point B is equal to 0. Now writing the equation of all the moments caused by the forces and couples about point B, we have our sign convention is clockwise couple or moment is positive and anti-clockwise moment is negative. So we have about point B, we see that there is an anti-clockwise moment caused due to this UVL of intensity varying from 30 kN per meter to 0. So the magnitude of this UVL is half into 30 into 6. It is acting at a distance of 2 by 3 of 6 meter span, that is equal to 4 meter. So we have minus half into 30 into 6 multiplied by 2 by 3 of 6 meter span. Next we have a clockwise moment caused due to the vertical component of this inclined force. Now the angle of this inclined force with respect to the horizontal of the beam is tan inverse of 4 by 3 which is equal to 53.1 degree. So the vertical component of this force is 300 into sine 53.1 which is acting at a distance of 6 meter from point B. So we have plus 300 into sine 53.1 multiplied by 6 meter. Next we have anti-clockwise moment caused due to the vertical support reaction VD acting at a distance of 8 meter from point B. So we have minus VD into 8. Next we have a clockwise moment caused due to this UDL of 15 kN per meter intensity acting for a span of 4 meter. So the magnitude of this force is 15 into 4 and it is acting at the center of this span, that is 2 meter from point E. So this force is acting at a distance of 12 meters from point B. So we have plus 15 into 4 multiplied by 12, and the summation of all these moments about point B is equal to 0. Now upon solving this, we get the value of VD as 225 kilonewton. Since the value comes out to be positive, our vertical support reaction VD is upward.